Welcome to the Bridges-2 webinar today. This will be a presentation by our colleague here at the PSC, Dr. Mei-Yu Wang. Next slide, please. So this is the Pittsburgh Supercomputing Center. I guess most of you know that because you're from the Bridges-2 community, but just, this overview slide. We've been around since 1986, and we've done good things, and we continue to do them. Next slide. And in particular, the slides and the recording will be made available on the website maybe by Tuesday or so, given the Memorial Day, but you will see it all. So this webinar is for the Bridges-2 project. So welcome to that. I guess again you're part of the Bridges-2 community, so you know about that. But this is an NSF funded Category 1 project, and yeah, it's good. And in addition to the resources, we also try to do outreach and education, and give an opportunity for the community to communicate the great things that everybody's doing. So next slide. I'm Sergio Sanilevich. I'm the PI of the project, and I would like to welcome you on behalf of our leadership team, pictured here. Next slide. And so the Bridges-2 webinars, we started them back in January of 23, but and if you follow that link there, you will find the recordings and slides of all the ones that we've had so far since January of 2023. And this is where you'll also find the recording and the slides for this one. So the idea is to bring in topics and speakers of interest to is being done by our community, or like, both accomplishments, but also ongoing research, forward-looking work. So if you have any future speakers to suggest, and it could be yourself or people from your own team, or you could just say, I would like to hear more about, the following topic, then just send me email at this address. Next slide. So we're happy to have Dr. Mei-Yu Wang present today. She is a member of our HPC AI and Big Data team here at PSC. And as you see, she has expertise in disciplinary science, astrophysics, and then, like I guess many of you, she started adopting AI machine learning as part of her research, and now that's, of course, the focal point of the work she does for PSC. And so, yeah, you'll see one particular thing that she's been working on. Next slide. So the logistics today, first of all, please refer to the code of conduct that we respect as part of, as an access NSF access resource provider. That indicates, like, ombuds people that you can contact if you have any issues that you observe. What we'll do today is all of us will be muted except Mei-Yu. And so Mei-Yu will have roughly 40-something minutes for her presentation. And while she talks, maybe just type questions into the Zoom chat. We may be able to address some of them. but then we have a dedicated 10-minute Q&A period at the end of the hour, so after Mei-Yu's presentation stops. And then Mei-Yu has graciously agreed to respond to further questions that may occur to you if you send them at her address there. And I think she'll also at the end refer to the general help@psc.edu address for general questions about Bridges-2. So any questions for me at this point? If not, then let's welcome Mei-Yu. Mei-Yu, please take it away.
Yeah, thank you, Sergio. So can you all hear me now? Just to make sure. Okay. So yeah, thank you for a nice introduction and welcome everyone. So the outline of this webinar is as following. So first I'll talk about two examples of popular open large language models, Llama and Gemma. So yeah, I'd like to clarify that technically Llama is not exactly open source, but for example, first you will need to submit a request to Meta to access the model, and second, for commercialized usage, there was still some restrictions. But still, since the release of Llama last year, it had quickly become very popular, especially among the open science community. And on top of that, this year, Gemma was released by Google, which is another open large language model, and the concept is more aligned well with the conventional open source. So I will talk about several features of this model and ways to get started and ways to access those models as well. And then next, I will give you some examples of techniques for fine-tuning models with limited resources, which is quite common unless you work in a big company for consumer-grade GPUs. This is typical problems, and there are already first ways to address those issues and provide solutions. For example, there are first techniques for doing parameter efficient fine-tunings or PFT, and I will touch on a few of them. And then I will talk about techniques such as quantization and fully sharded data parallel work for doing distributed training. And then, of course, I'll briefly introduce Bridges-2 GPU partition and first different features. Although in the Bridges-2 webinar last fall, where I talk about deep learning distributed training, where I give a more in-depth introduction about this part, but all the information can be found in the Bridges-2 user guide. So here I'll briefly describe, for example, the type of GPU nodes, partitions, how to run jobs such as batch or interactive mode. And also for Jupyter Notebook users, you can use on-demand to set up your run easily. And I'll also mention how to set up environments for your AI deep learning applications. And then lastly, I will do a demo to show how to perform model fine-tuning or inference with Llama-2 7B and Llama-3B, and optionally Gemma 7B using LoRa. But I will later point out that we have prepared a public GitHub repo for you to access those examples and give you instructions how to run those examples on Bridges-2, although those examples are actually modified and to accommodate the machine configuration of Bridges-2 by using examples from, for example, Llama recipe or Gemma websites. And then lastly, I will conclude and take questions. So let's dive into the first part. So Llama, which stands for Large Language Model Meta AI, is a family of autoregressive large language model released by Meta AI starting in February 2023. And right now, Llama is in the third generation. And for Llama-2 and Llama-3, they consist of models with different model size. For example, for Llama-2, it contains, for example, Llama-2 7B, Llama-2 13B, and 17B. And for Llama-3, it has Llama-3, 8B, and 70B. So those numbers represent roughly how many parameters are in the model. For example, for Llama-2 7B, that means it has about 7 billion of parameters in the model. So for each model, it also comes with the pre-trained version of the model, which is good for general purpose large language applications. And also they also come with either the chat or the instruction tuned version, which is good for dialogue type of applications such as chatbots. And there are also other variants of the model, such as Code Llama, which are specialized for code synthesis type of applications, and also Llama Guard, which can be used for classifying large language model inputs and responses. So along the release of Llama-3, they also released the performance among a few popular benchmarks. So in general, for comparing performance of Llama-3 with Llama-2, in the benchmark they have tested, Llama-3 had outperformed all the benchmarks they have tested compared to Llama-2. So this is one reason is largely due to the much larger data sets that have been trained on. So Llama-3 has been trained with a much larger data set, about 7 times bigger than Llama-2. But in general, Llama-3 has been performing pretty well, and here they show comparison with a few different popular models. For example, on the left, they compare Llama-3 8B instruct with Gemma 7B instruct and Maestro 7B instruct, which are two comparable open models that's available in the general public. And on the right, they compare Llama-3 70B model with two models. Actually, these two are currently closed source. For example, Gemini Pro 1.5 and Cloud 3 Sonnets. And these two, they can currently only access through API. And here they show comparisons with among 5 different benchmarks. For example, for MMLU and GPQA, those are challenging domain-specific questions, which are designed to measure AI's ability to understand wide range of subjects in different domains. And for human eval, this is a benchmark for understanding AI's ability to for code synthesis type of capability. And for GSM, AK, and math, those are math type of benchmarks, which consists of grad school math problem or challenging competition type of problems. So as you can see that on the left, for Llama-3 8B, it outperformed in all these 5 categories comparing to Gemma 7B and Maestro 7B. And on the right, for Llama-3 70B, in some benchmarks, the performance is better than the other two, and in some categories, it shows comparative performance. But among these 3, Llama-3 is 70B is the only one that is open. It's the open source model at this point. So so far, Llama-3 has Llama-3 or Llama-2 has been interesting model for open science community, and Meta have provided different resources and ways for you to get started with the model. And you can also find other resources. For example, they have been integrated with some of the popular Python libraries as well. So a lot of information you can find those from the Meta Llama websites. And for you to download the model, the first step is to go to the Llama website and submit the request. So they will basically ask simple questions like your name, your affiliation, and email. And then you can submit the requests, and they will send you email instructions about how to download the model, for example, those links and where to find the download scripts. But alternatively, you can also download from, for example, Hugging Face or Kaggle. But the first step is still you will need to register on the Meta websites. And you will need to make sure that the email you submit across those sites where your accounts are consistent when you are accessing the Llama model. And there are various different resources or examples that are available for you to get started to play with Llama. So for example, for Meta, they have provided examples for you to do Llama fine-tuning or model inference through the Llama recipe GitHub repo or their Meta-Llama/Llama repo. And for PyTorch users, you can work with the TorchTune library, for which it has been integrated with Llama to do model fine-tuning and inference as well. So next, I'll talk about Gemma, which is a family of lightweight state-of-the-art open model released by Google this year in February. So currently it has two different model sizes. So one is Gemma 2B and one is Gemma 7B. And similar to Llama, it also comes with the pre-trained model and the instruction-tuned version of the model. And there are other variants as well, similar to Llama. You also had a code-specialized version of Gemma called Gemma. And it also has a variant called Pauline Gemma, which is an open vision language model that has Gemma as the language backbone. And it also has something called recurrent Gemma, which has a distinct model architecture that leverage recurrent neural network and local attention to improve memory efficiency. So the performance of Gemma has been reported in the Gemma technical reports. Although at that time Llama-3 was not released yet, so here they only show comparison of Gemma with, for example, Llama-2 and Maestro 7B, although you have seen the comparison a few slides ago. But here, as you can see that Gemma 7B, although in general, those models are on the smaller side, compared to slightly larger models such as Llama-2 30B, the performance of Gemma 7B is competitive or better in some categories. And here they show performance in a few categories, but if you want to know details of which benchmarks they have run for those different categories, you can find those details in the technical report. So I also like to mention that Gemma in general is a little bit on the smaller side compared to Llama. So they only consist of about 2 billion parameters and also 7 billion parameters in terms of the model size. So the goal is that they want to provide efficient deployment and development applications using those models on GPUs, or for Gemma 2B, you can also be deployed on CPUs or on device applications. So that's one advantage of Gemma. So there are first different resources for you to get started with Gemma, and you can find many of them, of course, from the Gemma websites. And currently, there are a few different ways to download the model. For example, you can download it from Kaggle or using the Kaggle Hub API or Hugging Face as well. And if you're interested in knowing about more technical details, you can take a look at their technical reports. And for examples or scripts to get started with Gemma for fine-tuning, inference, etc., Google had provide various different examples, also several reference implementations in various different machine learning frameworks such as TensorFlow Keras or PyTorch. So you can find those from the GitHub, from their GitHub repo. And also it is integrated with TorchTune if you are a PyTorch user. So although Llama-3 and Gemma was released this year, so there are not so many papers yet, but so since the release of Llama, it had become quite popular in the open science community, and a few scientific application has been built upon Llama. And similar approach, of course, can be applied to, first of all, Llama-3 and Gemma as well. But in general, you can fine-tune the model with domain-specific knowledge. For example, here are at least a few examples, and there are associated papers, but this definitely is not an exhaustive list, and there are many out there as well. For medical specific large language models, you can fine-tune it with medical papers, medical conversation, clinical data, to build medical application for your projects. And for biochemistry domain, there are also research that has done to fine-tune the model using molecule or protein sequence representation with Llama to construct application as well. And of course, Llama also has been used for different domains such as finance, etc. And another popular way to use large language models such as Llama is to build a retrieval augmented generation pipeline. So, for example, for medical domain, this approach has been used for generating a disease prediction system or general purpose medical application as well. So next, I'll talk about a few examples of techniques for fine-tuning models with limited resources. So, in traditional fine-tuning, you may update all the model parameters when you are fine-tune the model. Although it is also possible to free some layers and leave the rest trainable, but in general, the cost for even just fine-tuning could be quite significant. However, in contrast, for parameter-efficient fine-tuning, the strategy is that you will freeze the base model or the original pre-trained weights of the large language model, and you will add some adapter modules on top of the model or your inputs and make those trainable. And that's where you will update the weights during the training process. And depending on the way you add the adapter and also how you set up the adapter, many times the number of trainable parameters could be reduced to less than 100% compared to the original model weights. So here are some examples. For example, LoRa, p-tuning or prompt tuning or prefix tuning, depends on where you insert the adapter or how you do it. They also provide different approaches. Here I want to explain in a little bit detail for one of the most popular ways to do it, which is LoRa, which stands for low rank adaptation. So in the figure on the right, you can see that this is an illustration of how LoRa works. So the blue square represents the original pre-trained weights, for example, the Llama pre-trained weights, for example. During the fine-tuning, you don't update the weights and just keep the weights frozen, and you add rank decomposition metrics like those as illustrated by these two orange trapezoids, and you adjust the LoRa parameters such as, for example, the rank of the LoRa to some small numbers, for example, that represent the dimension of the matrix in one end. And for smaller rank, that will make the size of the decomposition matrix smaller, and therefore the total trainable parameter number is much smaller. So yeah, that and only train those adapters or those adapter modules during the fine-tuning process. Okay, so for next, I'm going to talk about quantization. So quantization involves representing model weights and activations, which are typically represented by 30 bits floating numbers with lower precision data, such as 8 bits integer and 4 bits integer. There are other formats that's available, and some only supported by different certain GPU architecture. But in general, the benefits of quantization include smaller model sizes, faster fine-tuning, and faster inference. So this is particularly beneficial in resource-constrained environments. Technically, there are different ways to apply quantization, but in general, obviously the trade-off is reduction of model quality due to loss of precision. So here I list a few example libraries that are implementing the quantization and can be easily integrated, for example, with Hugging Face Transformer or PyTorch applications, so such as Bits and Bytes, Quanto, and Torch AI. And you can take a look of those examples for applying quantization to your applications. So next, I'll talk about one popular way to do distributed training, which is called fully sharded data parallel. So although it has this name data parallel in the model, but it's not the same as the traditional data parallel, for which you will maintain a replicate of the model parameter gradients and optimizer states on each GPU during the distributed training. And in contrast, for fully sharded data parallel, they shards also all these states of model parameter gradient and optimizer depends on your choice across data parallel workers or those or among multiple GPUs, and therefore it can reduce GPU usage, and also you can optionally offload the sharded model parameters to the CPUs. So this framework is available in PyTorch and is also integrated with Hugging Face accelerates. So you can easily apply this when you are doing distributed training with large language model and help with GPU memory usage. So for details, you can take a look at the paper if you want to know more details. So next, I'll give you a brief overview of the Bridges-2 GPU and describe several features of it. So in general, you can find all the details in Bridges-2 user guide, but here are some brief overview of the GPU and GPU share partition. So for GPU share partition, that is for jobs that will use part of one GPU nodes. So in general, most of the GPU nodes, other than the DGX2, they all have 8 GPU per nodes. So for GPU share partition, you can request up to 4 GPUs, and the maximum runtime is 48 hours. And then for GPU partition, you can that is for jobs that will use one or more entire GPU nodes. So you can request up to 64 GPUs, which is about 8 GPU nodes, and the maximum runtime is 48 hours. So so there are a few different node types for the Bridges-2 GPUs. So for example, they are divided into these 2 categories. One is V132 and one is V160. So in general, that is divided by in terms of the memory per GPUs of those nodes. So for large language model applications, because it is usually pretty memory intensive, and it is recommended that you use Phi-132 for most of your large language model applications. And although we have one DGX2, which has 60 GPU per node, and they are interconnect with NVLink. And but most of the Phi-132 nodes consists of Tesla Phi-132 gigabytes GPUs. And most of the time, you likely will request those for your applications. So there are several ways to run jobs on Bridges-2. For example, you can submit batch jobs for which you will prepare Slurm scripts and submit jobs to the queue so that they will run as soon as resources are available. You can also run with interactive sessions, for which during those sessions, when you type commands, you'll receive output back to your screen as the command completes. And this is best for debugging and short test jobs. And the maximum runtime is up to 8 hours per session. And if you're Jupyter Notebook users, you can use on-demand web interface to run your Jupyter Notebook. Although there are other first different features provided by on-demand, but here I will just focus on how to run Jupyter Notebook with on-demand. But for details, what on-demand can, what features on-demand can provide, you can look at the Bridges-2 user guide for details. And here are also several different ways to set up environments for your AI ML applications. So for example, you can utilize the Ph.D pre-built AI module, for which there are Anaconda-based environments that already have TensorFlow or PyTorch and several popular common AI application packages installed. And you can either just use those environment as is, or customize those environments for your own projects. And we also provide NVIDIA NGC containers, and those containers are developed by NVIDIA that are performance optimized and ready to deploy for your AI ML applications. And of course, if you want to create your own Conda environments or customize AI environments, or create your own Singularity containers, you can find more instructions here in the Bridges-2 user guide. So let me get into more details about how to run deep learning jobs, and then we'll get into the demos. So for interactive sessions, here are some example commands to start interactive sessions. So you will type something like this, and then specify, for example, type of partition, type of GPUs. So yeah, as I mentioned, for example, to request Phi-100 nodes that has 32 gigabytes memory, then you will need to specify, for example, Phi-100-32 here. And then it follows with the notation for specifying the number of GPUs you're going to request. And then you can specify the duration of the run, for example, 1 hour, 2 hours. But if you don't specify, the default will be an hour. And there are different, here we list, I list some of the rules for specifying the commands configuration, but you can find all these details in the Bridges-2 user guide. And for batch jobs, here is an example Slurm scripts, for which, as you can see here on the left, it has specific formats for which you start with a header, for which you specify several features like which partition, duration of time, type of nodes and number of GPUs, similar to the interactive sessions. And then it follows with the run commands. So for more details, you can find the more examples or different ways to configure the Slurm scripts in the Bridges-2 user guide. So next, I'm going to show how to run Jupyter notebooks with on-demand. But first step is to open this link, which will with a web browser, which you will be prompted to enter your Ph.D email and password. Sorry, Ph.D username and password, and then you will be led to a web page like this. And then for running Jupyter notebooks, you can click on this icon, for which you will be led to a web page like this. Then you can specify configuration of your job, such as requested time, number of nodes, which partition, and then you can specify type of GPUs and also number of GPUs in this column, extra Slurm arcs. So yeah, again, for specifying P132 gigabytes GPU nodes, you can do it here. This is one example of doing it. Once those are ready, you click on the launch icon at the bottom to submit the job. So it may show messages such as like it is sitting in the queue, but once the job started, then you can click on the button here, which says connect to Jupyter, and then you will be led to an interface similar to what you will typically see when you're running a Jupyter notebook. So you can browse through the Bridges-2 directory and find the Jupyter notebook you want to loading. And then once open the Jupyter notebook, one easy way to set up the environment is that you can load the NGC container for your PyTorch or TensorFlow application. So the way to do it is that on the top, there are several different tabs. If you click on the tab named kernel and then scroll down, select change kernel, you can see that the options for loading NGC PyTorch or NGC TensorFlow are displayed. So if you want to use custom conda environment or container, you can find instructions in the Bridges-2 user guide. Okay, so next I'm going to do a demo to show how to actually run jobs to perform model fine-tuning inference for Llama-2 7B, and also Llama-3B and Gemma 7B with LoRa. But depends on the time, I may just point you to the GitHub repo for which we host those examples and just run through one of them. But please check this GitHub repo and go through those examples by yourself at your own pace. And those instructions in terms of how to submit jobs or how to run them on Bridges-2 are given in the notebook markdown or in the README file. Okay, so let me switch to the so can you see also the GitHub repo now? Okay, I assume you see it, but anyway, so this is the GitHub repo.
We see it.
Okay, so this is the GitHub repo that is hosted under Ph.D. edu. So this is public available. So we provide a few simple examples, and actually those are modified versions of example extract from Llama recipe and the Gemma websites. But we just modify that a little bit to accommodate the machine configuration and give you example scripts such as Slurm scripts and example command for you to run it. So there are a few different useful tips that I would like to mention. So since those models are pretty big, so make sure when you download a model, you you do it in your project directory other than the home directory, which by default only have 25 gigabyte quota. And also, it is recommended to create a sync link for the cache folder because, for example, if you download the model using Kaggle Hub or Hugging Face, oftentimes you will just download it to the cache folder, and the default location is at the home directory. So you can use command like this to create a sync link to link the cache folder to your project directly. So yeah, oftentimes you may encounter a problem like this. So yeah, if I may not have time to go through all examples, but here, for example, we have provided instructions how to run Llama recipe examples to do fine-tuning inference with Llama-2 7B and Llama-3 8B. So here are some steps for running Jupyter notebooks with on-demand, and also if you want to run it with interactive sessions, batch jobs, we also provide example commands and Sloan scripts. And for Gemma, we also show examples that actually from the Gemma websites, how to run distributed tuning for Gemma 7B, and for single GPU, you can run LoRa with Gemma 2B as well. Okay, so next, let's actually run it. So if you click on the on-demand at bridges2.psd.edu, you will see a web page like this. Then you can enter your Bridges-2 sorry. So you can enter your Bridges-2 username and also password. Then you can log in. So while we're waiting, okay. So yeah, so you will be led to a page like this. So similar to what I just explained before. Then you click on the Jupyter Notebook Bridges-2 icon to start interactive app session for running Jupyter Notebook. So here I will select GPU share partition. And then here I would like to request one U132 GPU. But here I add additional flag, that is because I had a reservation, but usually you don't need to do it. But once those are ready, just click on launch, then you will submit the job. Okay, it may take a while. So it says it is the job is currently sitting in the queue, but it should start pretty soon. So yeah, just wait for that a little bit. Okay, so once that's ready, you will see this icon, sorry, or this button just appear, and then you can click on connect to Jupyter, and then you will land on your home directory like this. But usually you will create a sync link to connect to the Ocean directory. So you click on your own projects directory, and here I will download the Bridges-2 large language model examples, and I'll just run it here. So I'll run the Llama demo. So here, as I showed before, you can click on kernel on the top, and then select change kernel to load the MGC PyTorch container. And first step is to download the weights if you haven't done so. And because here we're going to use Hugging Face transformer library, make sure if you want to use those libraries, you need to convert the model weights to Hugging Face formats if those are not downloaded from Hugging Face websites. But this is already done and already installed the prerequisites, so I'll skip these steps. And then this commands loading the libraries, loading the models and tokenizers. So yeah, it may take a few seconds to do so, but yeah. So I guess meanwhile, is there any questions? I think it may take a few seconds, depends on situation, but yeah. If there's any question, I guess I can answer one or two at this point since it's still running.
There's nothing in the chat, but okay, here we go.
Yeah, I guess I can construct a red example, but for example, you can just use some popular framework. For Llama, you can use Llama Index or Longchan. I think in the Meta website, they actually have some simple examples, but I didn't go into this one in detail because that will be a lot of that will be out of scope of this webinar because I already cover a lot of things, and then probably I will need another it will be done on another time, but yeah, I think I can think about adding one, but not at this point. But yeah, okay, still loading. But maybe let me just proceed. But the example basically, it's going to do dialogue summarization, that kind of task. So we're going to fine tune the model with a data set that is that consists of a curated pair of dialogues and their summarization. So, so you can first check how the model is doing in terms of this kind of task before it is fine-tuned. So I run this, but here there's a example. For example, this prompt asks a model to summarize this following dialogue. So if I run it, which I already did beforehand, it actually didn't summarize the dialogue pretty well. It just repeats the dialogue, which is quite bad. Okay. So then we can see how it works after the fine tune, but okay. Yeah, I think for DDP, PyTorch DDP, yeah, I think for Marble nodes, you cannot just use the original Torch run wrapper. You will need to do something a little bit using MPI run. But yeah, so this is a little bit problematic in terms of running Marble nodes. That's true. Okay, let's see if this is done. Okay, this model is loaded. Let's actually run it. So I'm running the step of loading the data sets, which is called the Samsung data sets that consists of a pair of dialogues and summarizations. Yeah, I think you can build conduct environment with different Python versions. So I think in terms of CUDA version, I think I'm not sure how many different versions that is available. I think currently using 12. But yeah, I haven't tried with different CUDA driver, but for different Python version, that's definitely not an issue. Some smaller impressive. Well, for the question, what are some smaller language model that has impressed me? I'm not sure. Depends on your application. So, but yeah, but there are a lot of open source model out there, but a lot of them are actually on the bigger side. I think Gemma is doing quite good, but for smaller one, yeah, I'm not so sure. But yeah, I think Gemma is a good one to explore.
Mei-Yu, did you see Simon's question? Once you have a fine-tuned model, how would you deploy it?
Oh, okay, sorry. So so you have a fine-tuned model, you can let me just show it. Okay. So I have let me just go through a step and I will just show how it runs. So you can now since the model have been loaded and the data is prepared, then you can prepare the model for parameter efficient fine-tuning and you specify the LoRa configuration in the here, for example, and then you can do the model fine-tuning. So you would define the training arguments, and then here I have enabled 1DB, so that is a popular software for you to log your several matrices such as loss, or if you want to track precision or anything you like to add, this is possible as well. But yeah, so let me go into the next step. So you can still employ this. You can save the fine-tuned model, and then if you just want to evaluate how the fine-tuned model is doing, you can just use a step like this and ask the model to generate the response for your prompts. But I don't know if that is how what your question is, Simon, or you mean other different applications or things like that. But there are other frameworks if we are talking about such as RAG or anything else, then that would be another topic. Sorry, how to bring your own content. So for constructing your own containers, you can find it in the Bridges-2 user guide, but I didn't go into details here, but or I think one common way is to I don't know, but you could just copy the container image to the Bridges-2 directory if you already have that ready. So is that how what your question is, or how you load it to the Jupyter notebook?
Yeah, I mean, as you see, Kamal asks to see that slide again, but before that, are there any other slides you wanted to show, or like, because we haven't really seen your last slide yet.
No, I think that's all, but I don't know which slide he's referring to, so let me see. You mean this one, or this is just loading the NGC container, but for instruction to load your own container, you can find instructions here. And I won't go into details because there are first a few steps for doing so. Another slide examples actually. I don't know. I don't think I show a slide of the previewed container yet, but yeah, or you can send me an email offline. I don't know. But anyway, let me quickly go back to the example. But yeah, anyway, so this is still running. It may take a while, but yeah. So if you want, you can check the progress. If you use weight and bias, they will just log the progress, training progress, and along with some matrices about the system status. So this is some used for tool to consider. They will also keep a copy of the run configuration in the local directory. But yeah, since it's still training, so I have run this beforehand. So if you now evaluate the trend model with the same prompts, then so now you can see that it actually summarized the dialogue properly and actually is doing actual summarization. So yeah, I think this is roughly this example. So there are other ways to run the model. For example, if you want to run llama recipe, you can run commands like this. So for llama 27B, depends on the configuration, it can be done with 132 gigabyte GPU, and for llama 3 8B, you may need 2 or more 132 gigabyte GPUs. And you can do this using a command like this. You can either run it here, or you can run it with interactive sessions or batch jobs. Okay, so I guess since only we're at the hours, I'll just go back to the slides and show the conclusion slides. And so, okay, I don't see any further questions other than how to use your own containers. But send me an email after the presentation, and haven't deployed the model with the library that Garrett was mentioned. So okay, but in summary, so the release of open large language models such as Llama and Gemma provide big step toward democratizing large language model, and it has become popular for the open science community. So there are first different techniques for fine-tuning or inference large language model with limited computational resources. And Bridges-2 GPU partition, for Bridges-2 GPU, it's best to utilize V132 gigabyte GPUs to work with large language models, and Bridges-2 have provided various different ways to run those jobs, including batch, interactive mode, and on-demand web interface to set up runs for Jupyter Notebook. And please take some time to check the examples, and then email us any questions you may have. For general questions regarding Bridges-2, email help@psc.edu. And if you want to, if you have any webinar specific questions, you can send an email to me. Okay, I think that's
Yeah,
all.
well, thank you very much, Mei-Yu. Thank you, everybody, for attending. There was one last questions about just playing around maybe with the examples or being inspired, if you're inspired by Mei-Yu's talk. And if you are not already a Bridges-2 user, it's easy to apply. But if you have questions, help@psc.edu. And again, Mei-Yu has agreed graciously to also answer more questions if you send them to her email. So with that, thank you very much. Thank you, everybody, for coming, and have a great weekend. Bye.